look at a smartphone or a modern car and just wonder, how in the world did they actually make this? It's not just a brilliant idea or a giant factory. It's a seamless digital conversation, a conversation between three key pieces of technology. So today, let's dive into the digital thread that powers just about everything made today.
So, this is the big question, right? For anyone who makes anything. How do you get from a sketch on a napkin to a real, physical object that works perfectly, is strong enough, and doesn't cost a fortune to produce? That's the puzzle we're going to crack open right now.
All right, so here's our roadmap. We'll start with that fundamental challenge of just making stuff. Then we'll meet the three digital tools that are the solution. We'll see how they're supposed to work together, uncover a huge hidden problem and how they talk to each other, and then check out the clever solution, a kind of universal digital language. And finally, we'll look at where this whole revolution is taking us.
Okay, let's start with the big picture. Getting from an idea to a finished product is a massive race. A race against the clock and a battle against the budget.
You know, it doesn't matter if you're a tiny workshop or a massive corporation. You're under the exact same pressure. You have to innovate faster than the competition, slash your development time, and keep costs way down, all while making a product that's absolutely top-notch. You know that old engineering saying, right? Faster, better, cheaper, pick two? Well, the whole point of this digital system is to try and break that rule. So how do we solve this puzzle? The answer is a powerhouse trio of computer-aided technologies. You've definitely heard these acronyms, CAD, CAE, and CAM, but let's really break down what they actually do.
First up, everything, and I do mean everything, starts with CAD, computer-aided design. This is the digital drawing board. It's where that first spark of an idea gets sculpted into a super detailed, precise 3D model. You're basically building the entire thing on a computer screen before a single piece of real material is ever touched. And look, CAD is so much more than just making a cool 3D picture. It makes an engineer way more productive. It improves the quality of the actual design with insane precision. It creates perfect documentation. But the most crucial part? It builds the detailed digital DNA of the product, the master blueprint that's going to guide every single step that comes next. Okay, so you have your design, it looks great, but will it work? Is it going to snap in half under pressure? That's where CAE, or Computer-Aided Engineering, comes in. This is your virtual testing lab. CAE software takes that perfect CAD model and just beats it up digitally. It simulates heat, stress, vibration. Basically, it puts the design through hell to see if it can survive in the real world. And the benefits here are just huge. You can find every single weak spot in a design before you've spent a single dime on materials. This means way fewer expensive, time-consuming physical prototypes, and it helps you prevent those catastrophic, costly failures down the road. It really gives engineers the freedom to innovate without taking a massive risk.
All right, the design is solid, it's been virtually tortured, and it passed. Now it's time to actually make the thing. And this is the job of CAM, Computer-Aided Manufacturing. CAM is the essential bridge. It connects the digital world of the design to the physical world of the factory floor, translating that computer model into a language the machines can understand. CAM software creates these incredibly detailed step-by-step instructions called toolpaths. It then feeds those instructions to CNC machines, that's computer numerical controlled. These are the workhorses of the modern factory, the automated mills, lathes, welders, all the super precise tools that physically cut, shape, and build the final part with amazing accuracy, all based on that original digital design. Now, the real power here isn't just using these three tools on their own. The real magic happens when you connect them all into one seamless flow of information, what we call the digital thread. In a perfect world, the process is this beautiful straight line. The data flows from the design in CAD, it gets validated and perfected in CAE, and then it's sent straight to CAM to tell the machines what to do. This integration streamlines everything, cuts down on errors, and saves a ridiculous amount of time.
Here's a perfect look at CAE in action. This is called a finite element analysis. All those different colors, they're showing you where the stress is concentrated in the part. That bright red spot, that's a huge warning sign, a potential breaking point. Seeing this, an engineer can say, aha, we need to add more material right there and fix it in the model long before it becomes a real expensive problem.
But you knew there was a but coming, right? That perfect, seamless workflow, well, it has a major roadblock. While these systems are all meant to work together, they often come from different software companies, and they don't speak the same native language. This diagram just nails the issue. On the left, that chaotic web is what happens when there's no standard. It's a total mess. Every program needs a unique, custom translator to talk to every other program. But check out the right side. That's the elegant solution, a neutral file format. It acts as a central hub, a universal translator. Now each program only has to know how to speak to the hub, not to everyone else.
So why is this so hard to begin with? Well, sometimes the systems are just built on fundamentally different math. It's like trying to mix oil and water. Then you have companies creating their own proprietary file formats to lock you into their software. Add in the fact that technology is changing at lightning speed, and you've got a perfect storm for incompatibility.
So how do we solve this digital Tower of Babel? Well, the answer lies in those neutral file formats we just saw. We need a common language that any system can learn to speak. Let's peek under the hood of a classic neutral format called IGES. Think of it like a super organized blueprint. It has sections that set the basic rules, like what units we're using. It's got a directory, which is basically a table of contents for all the geometry. And then you get the real meat, the parameter data, which contains the exact coordinates for every single line, arc, and curve. It's a completely self-contained digital recipe for the part. And this right here, this is where it all clicks. On the left, a simple engineering drawing. Now look at the right. That wall of text, that is the IGES code for that exact same part. Every line, every circle, every dimension from that drawing gets translated into that structured code. And that code is the universal message that any CAD, CAE, or CAM system can read and rebuild perfectly. The drawing literally becomes a language.
Okay, so let's zoom back out. We've built the model, we've tested it, and we've created the instructions to make it, all while making sure the data flows smoothly. So what's the ultimate payoff for all this work?
This quote just says it all. Calculate twice, so we only test once. That's the power of this whole system. It's about doing all the hard work in the digital world, where it's fast and cheap. You can run countless simulations, find every weak spot, and perfect the design, all before you ever make a single physical part. It saves an incredible amount of time and money, and lets you bring much better products to market way faster. And this digital thread, it doesn't just stop when the product leaves the factory. The next frontier is connecting this entire system to the Internet of Things, or IoT. Imagine having sensors on the factory machines and even on the products out in the real world, constantly feeding performance data back into the original design models. You get this continuous loop of improvement. This integration has already completely revolutionized how we make things, transforming product development from a series of clunky, disconnected steps into one fluid, digital conversation. So the question I'll leave you with is this. What becomes possible when that conversation extends beyond the factory to include every machine, every product, and every single user in the world?